My name is Chase Nelson, and I'm going to be showing you the Lewis structure for carbonyl sulfide, which is OCS. Now, if you take a look at this structure right here, you're going to see that oxygen has 6 valence electrons, and then carbon has 4 valence electrons, and that's carbon, and sulfur has 6 valence electrons, which give you 16 valence electrons total in this compound right here. And if you go and look on your electronegativity table, carbon is the least electronegative, so it goes directly in the middle, and then your sulfur and oxygen surround it. So we're going to form a bond between carbon and sulfur, and then a bond between carbon and oxygen, and then we're going to distribute 16 valence electrons, or until we run out, until we fill the octets, or until we run out of electrons. So let's fill oxygen. So now we have 2, 4, 6, 8, 10 electrons we've used. We'll fill sulfur, and 2, 4, 6, 8. 2, 4, 6, 8, 10, 12, 14, 16 total. So we have used all 16 of our electrons. But we have a problem. Carbon's octet is not filled. So we have to sit here and look at it. What are we going to do? Well, best thing to do right here is to get rid of 2 of sulfur's electrons, get rid of 2 of oxygen's. We'll rewrite this to make it clear. See if I have a better marker in here. There we go, that's a little bolder. Carbon will form now a double bond with sulfur and a double bond with oxygen. So, after we form the double bonds, we'll go back through, put 2 right there, so 2, 4, 6, 8, oxygen octet is fulfilled. Put 1 right there, 1 right there, there, 1 right there. 2, 4, 6, 8, sulfur's octet is fulfilled. 2, 4, 6, 8, carbon's octet is fulfilled. Now let's go back through and make sure that 16 valence electrons are there. 2, 4, 6, 8, 10, 12, 14, 16, 16 is being used. So, right now, our octets are fulfilled, and we have 16 electrons right there. So that Lewis structure is great and good to go. Now, you can tell, if you look right here, you should be able to tell what the electronic geometry and what the molecular geometry is. If you can't, I made a structure for you. Little homemade little thing right here. If you look at this, the blue balloon represents carbon, the orange balloon is oxygen, and the yellow balloon is sulfur. You have an electron trying to escape there. And the cotton balls represent the electrons. Now you can tell the double cotton balls on carbon and oxygen represent the double bonds. Okay. Now, if you look at this sucker, this is a better demonstration. The molecular geometry and electronic geometry is linear. Now, if you're wondering what the bond angles are, it's easier to tell on this sucker too. The bond angles are 180 because from sulfur down to oxygen, you have an 180-degree angle. Now you can also tell the type of bonds that carbon has with oxygen and carbon has with sulfur by looking at your electronegativity table. If you take the electronegativity of oxygen, which is 3.5, and subtract carbon's, which is 2.5, you get a 1.0, which means it's a polar covalent bond. So this is polar covalent. Now if you take the electronegativity of sulfur and carbon, carbon's still a 2.5, but sulfur is a 2.5 as well, it makes that bond a non-polar covalent. But the entire structure, if you look at the entire structure is a polar structure. Why? Because of the bonds. It has a regular shape and no symmetry. So that causes it to be a polar compound. Now just one more time before we all leave, I'll show you my little structure. We'll fit this up just real quick. Your carbon is your blue, yellow sulfur, orange is oxygen once again. You have your valence electrons as the cotton balls. You got your 2 up top for carbon, 2 on bottom for carbon, 2 in one bond, 2 in the other bond. So 2, 4, 6, 8, oxygen's fulfilled. Sulfur, 2 up top, 2 on bottom, 2 in one bond, 2 in the other. So that's 2, 4, 6, 8 in sulfur. And then 2 in that bond, 2 in that bond, 2 in this double bond, 2 in that double bond. So 2, 4, 6, 8 in carbon. So they are fulfilled. It is a linear structure on the molecular and electronic scale. Also, this is a polar compound with a non-polar covalent bond right here on carbon and sulfur, and then a polar covalent between carbon and oxygen. There is 2 double bonds, and that is the Lewis structure for carbonyl sulfide OCS.